feed the supply to the load to compensate additional requirement. Otherwise, it can't. So I can generate what is this? Randomly generate time of the day and randomly generate the state of the charge of battery. Then later on, I will check the one condition. What is the condition? If I created, that means 0 to 10 hours. Okay, in that time, state of charge is less than 50. If it is 50 means what you want to do, we have to give it is battery required to consume power from the what is this, our grid. So that on this condition, it will be consume power from the grid. That means that is the way I indicate here minus of 20. If you minus of 20, whatever thing you got put in. Okay, here I am making as a 20 is a marginal. Okay, later on from 20 to 10 else, later on it will be check one more condition, that means 10 to 12. Or during the conditions, the battery is exceed the power above 50. So at the time what happen? It will be speed the supply to the load. One more condition. Then between time 12 to 18. At the time, what happened? It will be check battery state of level between 12 to 8 hours. If this time, if condition is above 50, it will be feed the supply. In case it is not there, it will be store this. That means it will be drawn supply from load. This kind I make a what is this small conditions. So finally, I'm convert this data as that means matrix format with the help of this small code. Okay, so here already you know the neural network recorded two input. That is input is one is time, another state of that is means the state of charge of battery. Then it is one output. That output is whether either it is required to need to charge or it is need to feed the supply to the load or not. Okay, this is comes under the output of neural network. So I train the neural network. Neural network, how it is we can train in what is this in MATLAB environment. That command is nn star. So this is pop-up window will come. It is a neural network block. Here I am selecting fitting up. In fitting up, welcome to neural network. We start to create a neural network. Then click next button. Here input data is just I have run the simulation. So okay, first I run the data set. Data sets are created. That means this is the input data. This output data. It is data one is represents the input data. That is it has the value of this is temperature and corresponding state of charge. Sorry, time of the day as well as state of charge. And output is whether it is required to depends upon a condition. It is required to feed the supply to the grid or otherwise it is consumed supply from the grid. Okay, this is the output. Once we generated, here we have to select a data for input data is here data 1. We have to select. Then what's the target is output data, that means output. So that we are converting as a matrix from column to matrix row. Then click next button. Then here asking validating data. That means training purpose 70% of the samples are which is used to for training the neural network, and validating remaining 30% from 30%, 50% for validating, remaining 15% for testing. Then we have to select number of hidden layer. Here I am default I can use 10. Then it will be here you got to see on pop-up. So train neural networks is trained. Here we have to training algorithm. We have to select here 3 type of algorithm. It will be that default LMS, PS and SCG algorithm. Here I am using LM algorithm. Then for train the neural network, we can train the neural network. If you are clicking this new button, it will be train the neural network. Once the training is over, whether our training and data, training and actual data is perfectly matched or not, we got to test with the help of the regression plot. From the plot, you got to see R value is 0.9. So it is not. I am not getting proper. I think accurate is 1. If R value is 1, you got to get exactly match the training data with what is the test sample we have. But here R is 0.99, but anyhow it will be near to 1, so that I am not ignore this step. Then I go to the next step. Okay, training is over. Then we have to deployment. We have to do simulation deployment. Because of here, I'm not at all going to generate any application, any code, any graphics. Here, I'm going to generate simulation deployment. If you are clicking here, it will be generate simulation deployment on here. Okay, it can be used to future purpose. So already I did this is in proper way, so that I'm not using this is. Okay, so this is a trained neural network. So it is recorded to input, that is called as a time of the day and a state of charge. Okay, we fed to the here, then it will be generate command. That means it will be generate positive command means what happen? It will be consume power from it will be feed the supply to the load, depends upon load. If it is generate negative command, it will be store the supply from battery. Okay, here it will be current battery modeling is there. It is a total entire setup to control the battery storing unit. Okay, so what are things is that battery charging controller. The controller output is fed to the inverter control unit. Inverter control depends upon inverter control unit. The inverter will be control the supply which is fed to the battery. Input cap DC link is there. It will filter only fed to the DC supply to the battery. Okay, right. So this is a now simulation model is ready. Just we have to run the model. So it will be run 24 minutes. Okay. So already I run the model. What we got this kind of output. So what is the difference between this output and the previous one thing what we have? Previously you got to see grid feeding power is touches to the 150 peak. Okay, between 10 to 18 hours. It will be touched to peak value. So here you got to see now at the time of a same load, that means peak load is 150 only. But how it is compensated with the help of this battery unit. With the help of this battery unit. You got to see up to off peak period it is negative. That means it does not supply any source to the load. Okay, whenever load will be increased above that value, that means during the 10 hours, at the time of 10 hours, it's automatically battery will be feed the supply to the load to compensate additional requirement for that means source from grid. At the same time, remaining all the units are whatever supplies required, each and individual unit will be same as what we have experienced in previous case. Here you can see, in this case there is no modifications. The same power load will be same, but the peak this peak only supplied by battery. Peak only supplied by battery. So this is way we control energy management with the help of MATLAB platform. It's a very simple model. So next, what I now right now I'm working on this project only. So later on, what I plan, instead of neural network, I can put as a fuzzy logic block here. So at the time, what is the error? That means R value not meet 0.99. So I try to make it as a 1. If this is not possible, then I go for but this is an ANFIS model. If it is then finally we make a conclusion which one is better, which one is feed a more efficient supply to efficient output. Okay, right. So anyone have query, please raise.
I request the participants to please raise the queries from your end if you have it. Dear participants, if you have any queries, please. Sir, I have a small question, sir. Can I ask you, sir?
Yeah, tell me, sir.
Sir, what is the role of deep neural network in this application, sir?
So here, sorry, sir. Here up to now, I am developing only neural network ANN. So later on, I will develop deep neural.
Okay. So if deep
Here,
neural network is supposed to be implemented, then in what aspect it can be? I'm
what
just
I
out,
my expectation is
sir.
it here. Okay, here you got to see, sir. Before first, without a control algorithm, load profile is somewhat differ. Let us see,
Sir,
sir. It's an
sir,
individual load. This is a original load.
sir.
Load 1, load 2, load 3, load 4, load 5. Okay, sir. So each and every individual load profile you got to observe it, sir. At the same time, finally what I got, this is not matched with what I expectation. Okay, it is somewhat deviating. So I have to tune my control algorithm further.
Okay, okay. So thank you, sir. Thank you for your presentation. And I request anybody, if you have any queries from your side, please raise it now. As the topic, as sir is working on a real-time project, if you have any queries, you can ask sir now only.
And one more thing, I'll let you know all the faculty. Just I'm beginning level related to ANN with application of power system. So this is one kind of project. Apart from that, I'm working on MPPT technique. So if anyone interested, you can join with me. What is the outcome? You possible to get one SAF application after 8 months. It's open to all faculty, irrespective of department.
Yeah. And yes, sir. So it's actually an interesting topic which you have shared with us. Possibly,
Okay.
probably in future, if we can also see the possibility of implementing deep neural network concept in such type of applications, then as you said, it can convert it. We can convert it into a good publication also. So at this
Okay.
moment, I thank Dr. Mari Prashant sir for his real-time practical explanation, and which would be useful for the young researchers as well as the faculty of our college, followed by students. So I thank each one of you for your participation in today's lecture series. Thank you, sir. Thank you very much. We can leave. You can leave the session now. Thank you. Thank you.
Thanks. Thanks. Thank you all.